All right, so let it go in background. It is in the YouTube channel. Welcome you all. There are, okay, two more waiting. Let me just admit them. Admit. Okay. And okay, welcome again this semester, fall 2020. This has been a strange year for many of us, or most of us, and many things are going on in the area. And we have this one class cancelled last day. So let me, so I was planning to do some experiment with this online Zoom breakout room and everything. So let me do that today as well and try things. Let us start with a simple poll. Maybe how do I do that? It is about, maybe, let me take a poll on this ongoing wildfire situation. And let's take just a minute maybe to respond to that. So I'm launching the poll. And let's take a minute, please make sure you respond to that poll. Maybe we'll close in a minute. So let me see how the poll goes into the YouTube video. So YouTube video doesn't know anything about the poll. Maybe, and by the way, all the polls I think I marked them with anonymous, so you can select anonymous polling. So if you are comfortable with that, okay. Okay, I don't think this can be done. Okay, I think maybe we are all done. Let's end polling. So I see that none of you needed to evacuate. That's good, wonderful. Received warning for evacuation for 9 students. Please watch out, take care, make yourself prepared with all the emergency kits. Staying at home, but work air quality is poor for 31. Yeah, for most of us, that's the case in the Bay Area. Not affected, 6. Very good, wonderful news. So let me end poll and let's see how it goes. Okay, okay, there is poll coming up. Share the result. How about sharing the result? So what happens like when we share the result? Do you guys see the poll result? Anyone can speak up?
Yeah.
Yeah. So it's coming on your screen, right?
Sure.
Oh, okay. So that's how it works. Okay. So stop the sharing result. Great. Okay. Now, since I have fun, let me do some general assessment that I meant to do last day with you guys. So let me pull out the poll. Polling. This is a general assessment. It has about 3 questions. So maybe let's take a minute to answer the 3 questions. I'm launching the poll. Yeah, so okay, what I'll do, I'll also share my screen, that polling window live, so that in the live session it will go. I'm just sharing the screen. So let me see the No, okay. Seems like live doesn't catch the poll. Okay. All right, that's a learning for me. Okay, then I can stop share. Okay. Maybe we'll take another 15 seconds to end the poll. Okay, I'm ending the poll now. Okay, and let me share the result. And how do I share it on the YouTube screen? Let me see now. So as far as the polling result goes, there are a couple of late registered students. And I believe you are all registered now. You have the Canvas access. Okay, good that most of you are familiar with the Boolean algebra. That's great. For those who are not sure, this is something like a logic algebra, and that you should have had in the Math 42 course. Maybe it's termed different. Please go back to those material and see if they're done there, or if not, then please send me an email. Okay, so saying that you are not sure what is that, I can help you through going through that materials and determine if you have that or not. Programming assignment, as expected, CS department, everyone knows Java, good. C, C++, some of you, Python is picking up, Ruby, HTML. Oh, no one has done Haskell, Scala. I thought these two are more like in language studies. Maybe you haven't gone through those courses. That's okay, I believe. Okay, so this is wonderful, great. And still the poll result are not being shown on the webs on the YouTube channel. Okay, that's not a big deal. Okay, now I have another poll. Let me see, stop share result. All right, and this poll is probably I will do every day, beginning of the class. This is about the class preparedness and see how much I have done. So you can take it anonymously, as I said, if you want to. So it has again 3 questions. Let's take a minute or minute and a half. I'm launching the poll now.
Professor, I think you're muted.
Oh, sorry. Thank you for noticing that. I think I can end polling. I think all you have answered. And let's see if I, okay, let me share it. Let me share the result. So let's see, the first question was, have you watched the lecture video for today's topic? All of them, 35%, good. None of them, 27%. Please make sure you have time for this group. Some of them and none of them. Please make sure you watch the videos. Basically, those will prepare you. These are the class, like in this, as I mentioned, like in this classroom, I won't lecture. You guys ask me questions, I will clear up your doubt, we'll do some hands-on problem solving discussion. So no lecturing. Okay, so basically you need to go through them, make sure you don't fall behind. Otherwise, this class won't make sense. Same goes for this. Have you read the lecture notes for today's topic? 29% yes, no on 33%. Sum and part is 38%. Yeah, sum and part is better than nothing, of course. But please make sure you get time to do so. And about the queries, there are 8% says yes, you have noted your queries in the corresponding discussion page. Thank you for that. 46% no, and 46%, I think all of them you don't have a question. Don't have a question has one meaning of it, or at least two meaning it has. Either you read through and you understand everything, or you haven't understand anything. So you don't understand anything. For that situation, you won't have a question. And you have understood everything. In that situation, you won't have a question. Usually what I find, you have understood everything, that's not the usual case. That means if I see if you don't have a question, I would assume that you don't understand anything. Okay, you need to have a question. And even if you think, okay, if you think yourself that's a stupid question, maybe I don't want to, like put it on the note, something like that, or the Canvas discussion page. In this class, there is no stupid question. Every question is valid. Every question is important. Don't be shy to actually add them to the Canvas QA session. Okay, so let's do that habit. And I'll come back to this poll every day at the beginning of the class to see how prepared you are for this class. All right. Now what we shall do is, let me go to the Canvas page and look at the discussions if we have any. Let me see. So Q&A. Okay, all right, let me share that. Share this one with you. Okay, so I have this module 1 Q&A. One question from Carter: is a registered file where the stack file is located? Answer is no, actually. This is a good question. So we'll see, like down the maybe 3 or 4 lecture down the line, we'll see about the convention and usage of all these different components that you are reading in this lecture. Register file is not the stack that you learned from the software programming, the stack memories and heap memories. They are not. Stack memory and heap memories, all this part are basically software convention. There is nothing specifically on the hardware side, like the one you are, if you look at the memory chip or the memory card, there is nothing specialized hardware for the stack memory or specialized hardware for the heap memory, nothing like that. It is all memory, okay? And It is only the software convention. Software convention in the sense at the operating system level, operating system kind of segregate this memory space into different part for different target usage. Okay, some part is targeted for stack usage, some part of targeted for heap usage, and so on and so forth. So we'll all learn all of them, all of these conventions uh, down the line in 3-4 lecture. So let's wait for that one. Okay, so this is like a software convention, nothing specific to the hardware. Now, what is the register file? Register file, actually, this is the one you cannot access directly from the high level language. Okay, this statement is wrong. Okay, but let's take it for time being that you cannot access them from the high level language. Let's say you are programming in Java. Okay, you are making a software program using the Java language. There is no instruction available at that level that you can go and access register file directly and manipulate value into that. These register files are usually associated within the processor itself. Like if you take out the hardware, the motherboard, and then you pick out the processor like Pentium or whatever, ARM, whatever your system has, it is basically a part of the processor, register file. What is the usage of this? This is a scratch paper, you can say. Like it is just scribbling for the processor. It kind of scribbling and storing temporary values, which you cannot access from high level language. Saying that, this is not entirely true. The one who knows C programming and C++ programming, there is a way to actually go and directly access those register files. That's the beauty of C programming. That is very low. You can go really low level with that. But other than that footnote, C, C++, you can really see. I should not see even say even C++. Through the C language, you can access the register file from the high-level language programs. It can be only accessed through the assembly level program, that where you can actually directly manipulate the register file. So does it make sense, Carter?
Yep, that's clear. Thank you.
Okay, all right. So if you don't have any, or if you have not noted question here on the discussion page, you can ask at this point, or let me see. Yeah, just don't type in because, okay, let me see. I'm opening the chat. Oh, okay, so these are no question. Yeah, please don't ask question on over the chat. I usually don't look at the chat, so just speak up if you have question. One more thing, I'm seeing that some of you have turned on the videos. Thank you very much. This is a good way for me to connect with you. Others, okay, videos are optional. Of course, if you have some concern on the bandwidth or privacy or any other stuff, you don't have to stream in your videos. But I would suggest that you at least set your profile picture, okay, so that I know your face. All right, I see many of you don't have profile picture up yet set up on the Zoom. Please make sure in the next class you set up your profile picture as a face, your face. I can clearly see, at least I can have some human touch through this pure online class. Okay, so let's do that. All right. So if do you have questions, anyone?
Professor, I have a question.
Yes, Narinder.
So my internet connection is really bad, and it might like drop me out of the class. Do I need to like send you a message to get back in,
No,
or
I have opened up the waiting room so you can join back.
Okay, all right. Just wanted to know because you did mention that you want us to join 5 minutes earlier, so that way people are not coming like late and disturbing the class. That's why I asked this question.
Right, right. So your situation is specific, special situation. So I don't want people to have a habit of getting into class late. So
Yeah.
that's why that thing is. But if you have a technical problem, of course, it is considerable. Yes.
Thank you.
Okay. Now, if you don't have a question, I want to try this new Jamboard. Okay, let me see if it is effective. Okay. How can I do that? Yes, this is my Jamboard. And I believe, okay, I'm sharing it with you. And I believe you also have a direct access to this Google Jamboard from the canvas. You can also watch out there. And I'm stopping my video now. And I want to describe uh, a little different perspective of computing system. Uh, so to do that, let's understand what is a computing system, and let's understand from a actor reactor relationship. Okay, it is something like I'll start drawing and trying to use it in a Jamboard. In the meantime, if you have question, just ask it. Like you don't need to raise hand or anything. Just ask me over using your audio. And if my audio quality is low, please let me know as well. Okay. So, so you can think a computing system as an organization. Organization as in the sense that let's take an example. San Jose State University is an organization, right? And this university has different people, and these different people have their different role in this organization. For example, like it has like dean of this college, or let's say start with a VC, vice chancellor of this college, and then it has a dean, and then it has basically then it has a department chair, and then it has teachers, then it has students, right? These are all, this person makes together this whole organization of San Jose State University. Similarly, computing system has couple of like role player in the whole model, okay? One of them is a memory, okay? One of them is a memory. One of them is memory. And what this memory has, it has, let's say it has a lookup table. Like you are all familiar from the programming language, a lookup table. Okay. And, or maybe, okay, let's not thought about the lookup table. Let's say this is an array, okay, array of information. And each has an index, like each array as an array variable. You're familiar with the high level program. It has the index to access the information within it. Okay, so let's say these are the indices: 1, 2, 3, 4, 5, some number, some n number. It has a huge storage. And then you can ask this guy that give me info at A. So what is A? Let's say give me information at 4. Okay. Let's say 4 has some values in it. Let's say it has some 104, some value. So what it will do upon getting this instruction from someone, it will give back that value to whoever is asking. Okay, that's one thing. Now, what you can do also with this guy, you can say that, okay, store at, let's say 2, some address. So we call these indices as address. And also we supply the value. Let's say we supply something like 91. Okay. So what it will do in that case, the memory will store value 91 to the address 2, which is indices 2. So it will store the value right there at 91 value at there. So that's the role of the memory. Okay, that is the primary role of the memory. So it maintains information storage in terms of values, and you can do two operations. Either you can tell it to store something in the storage, or you can ask it to retrieve the value from the storage. That's one thing. Now some more detail about this storage itself. The storage itself. Okay. So a memory has many these parts to store the value, individual values. And what it does, like from the software convention perspective, we have some convention of which memory should be used like what. Means, let's say we divide the whole memory into like several parts. Mainly, we'll see this in detail later, but just to have a concept, some part we say them, those values we store will be using as a data. And some part will store, we simply use as an instruction or program. So the memory storage space has two parts mostly. One is part is used for the data storing, and other part is to store the instruction and program. From memory perspective, memory does not differentiate between data and instruction. Instructions are represented as values. We'll see down the line in the lecture. They're all represented with some values. Okay, it is a numerical value, or I would say it is a bit pattern. Okay, we'll see down the line in the lecture. And also data is of course stored as a value in the memory. So in the high level program, you don't probably face it like you used to save it like a string or a character or Boolean or all different sort of data types. But down this hardware low level, everything is value. Everything is a bit pattern. Okay, there is nothing specialized for string or Boolean or character, nothing like that. Everything is value. Everything is stored as value. Even if the program you are writing that is ultimately goes and translated into set of bit patterns that is stored in the instruction part of the program. So that means it has as one specific significance, that whoever is using this memory object or memory as a character, you can either retrieve a data or an instruction. First of all, memory does not know. Memory only knows that it takes a request, whether, okay, retrieve data from this index or retrieve data from that index, and it just returns back the value. It is only up to who is the user of that information to make a differentiation whether that value returned, it will be used as a data or it will be used as an instruction. Okay. Any questions so far? All right. Now let's move to the second part, which is like another one. The most important one is a CPU. Or let's call it a processor. CPU is a big one. Processor specifically. Okay. So what it does, it basically does this. Okay, let's take some assumption that let's assume let's say 1001 to 9000, okay, 999. It is a program storage, means all your programs are stored in these indices storage. And let's say from 000 till 1000. Just an arbitrary assumption, nothing, don't take it very seriously on this, just to clear up the concept. It is basically the data part, okay, from these address ranges. Now, what this processor does is basically do this. Let's say it has an instruction linkage to the memory, and also let's link them, and it can say it can receive value from the memory, it can send value to the memory. So when it starts, it basically say that, hey, give, or let's use some formal term, read at address 1001. Okay. Let's say, so memory gets that instruction from the processor, and it reads the value from that area, Let's say this is an area 1001, and it has some value stored, right? And let's say that bit pattern for that value represent an instruction 1. So it returns back that instruction. Okay. Let me not use the instruction. Okay. So let me just use the value there. Some value from this area, right? 1001. Now processor at that point treat this value, this guy, as an instruction. It knows it can decode what the instruction is out of this bit pattern of the value and take an action based on that. Okay, let's say this instruction said something like add 2 plus 3. Very simple thing. So it knows what to do for this instruction and it evaluates that to, that's a 5. Okay. Now, next what it does, it basically tells something like this. write at, let's say, maybe 10, and it sends the value, this one, value of 5. So what happens at this point, the evaluated result gets stored at that indices. Let's say, I don't know, somewhere here there is this 10. Let's say this is the index 10. So it stores the value 5 right there. And this process, and next what it does, it basically sends a write, okay, read from 1002, means the next instruction. Okay, so first instruction, it gets, executes that, maybe it need to store the value back, it stored the value in the memory, and then it reads from the next instruction address, let's say 1002, and get back from there. Okay, so that is the whole basic concept of how a computer works. Question so far?
I have a question.
Sure.
So
Harrison.
the processor, yeah, Harrison. So the processor sends instructions to the memory, or the memory sends instructions to the processor?
That's a good question. So processor sends instruction to the memory in the sense, it's, you can think of use as a command. It sends some requests, some commands, or some instruction to the memory in the sense of read something, write something. Okay. The instruction, the other instruction that I was telling, that memory sends back the instruction to the processor, means memory doesn't know anything about instruction. It just sends back the value. Let's say it is saying that read from 1002. Whatever value is stored in the 1002, it basically sends back to the processor. And processor then treat that bit pattern of the value as an instruction, as in the user program. Make sense? Or
Yeah. Thank you.
okay,
Thank
so
you.
here I know this little bit confusing instruction to memory and stuff like that. When I talk about a processor sending an instruction to the memory, it's not your program instruction. It is basically, and you can treat them as it's sending a command to the memory that do this, do read, or do write. That's all, right? Memory just know these two things, either to read from a location or write into a location. That's it. Nothing else it does. Okay. Now,
Yeah.
one more concept. So here I'm seeing that there is two lines. One is coming, the value coming back as a read operation from the memory into the processor. So this is line one. And another line, which is, let me just make this color. Okay. So one line coming from the memory to the processor, and other line going from processor to the memory. Now, think that this memory and this processor are the real entity on a computing system. Okay, means like if you open up the computer motherboard, you will actually see some real hardware chip as a processor, big one, and some chip which is a memory. Okay, real hardware, real electronic devices. And there are electrical line connected between them to transfer this information back and forth electronically. And these informations, let's say our system nowadays are more like a 64-bit system, like most of you have 64-bit machine. If you are unsure, just look at your laptop spec or desktop spec and see that what kind of processor you have. So what does it signify, 64-bit machine? From this point of view, like electrical connection point of view between processor and the memory, these values are all 64-bit, and this line from processor to memory is also 64-bit. Now, if we drill down, this signifies that there are 64, or there should be 64 physical electrical wire, electrical line you should be able to see going from the processor to the memory, and another 64 lines from the memory connecting to the processor. Okay, I'm not even talking about the other line. Let's only talk from the data or value perspective. Okay, and when I talk about a data from memory point of view, data is everything. Memory does not distinguish between data or program. It's everything is a data, everything is value to it. Now, where I'm going with that? With that, that means we will see 128 electrical wire running on the motherboard from processor to memory, which is too much, to fit into a small motherboard, okay? Because there are many other hardware elements to connect with the processor and so on and so forth, not only the memory. Memory is the main part, but there are many other things. So what happened there? Basically, we simplify the whole thing. Let me just change the board and second board, let me draw it a simplified version. So my memory and I have my processor. And I have, you will find in reality, number of line goes between these processor and memory are 64. And they have one trick. They are bidirectional. Now, what does it mean, a bidirectional? If you look at the previous diagram, you see, like, when you are reading from a memory, you are using basically this line, right? You are using this line. Let me mark it. You are using this line when you are reading. And when you are writing, you are basically using this line. And of course, you cannot read and write at the same time, because it's the processor who is either trying to read from the memory or trying to write back to the memory. It cannot happen in the same time. It cannot happen in parallel. So that means we have a choice of just make one connection to transfer the data, okay, bidirectionally. So if it is a read, then it will carry data from processor to memory. So this is read. And if it is write, oh, sorry, my bad. If it is read, then it is this direction. And if it is write, then data or value travels in the other direction. But physically, they are the same electrical line. And that's why we are marking them as a bidirectional sign, so that we signify that these 64 electrical line carries values bidirectionally from processor to memory and vice versa, depending on whether we are reading or writing. Okay. Question so far? All right. Now, how about the other one? So other information we need always processor need to give to the memory is a which index from which it need to read or which index it need to write. So we call it an address line, which is always unidirectional because address is always produced from processor to the memory. And for 64-bit system, ideally, processor need to produce a 64-bit value as an address or index for the memory. So this is an address. And the other one, we call it a data. Okay. And one more terminology, let me explain that. Since this line is implicitly, we are marking it like an 64-bit line, assuming that we are actually, this is not one single electrical line between processor and memory, but it is composed of 64 individual electrical lines. They call it a group of such line is called a bus, address bus. Similarly, data is called a data bus. And instead of writing down specifically 64-bit, we represent like a slash. Sorry. We represent like a slash. That means it's a group of signals or electrical connection going from one end to another, which has total of 64 together. Okay. In this course, we will stick together with a simpler system for 32-bit. Okay, let's concentrate on that one. Let's make everything 32-bit. Because from now, this point onwards, we'll always talk about 32-bit, not 64-bit system. So 32-bit of address bus and 32-bit of data bus. Data bus is bidirectional and address bus is unidirectional because processor is the one who always generates an address for read or write from the memory device. And then how the processor is going to tell the memory whether to read or write. Okay, so we take care of the address, we take care of the data. So there are two more lines goes on from processor to the memory, which is also unidirectional. One is let's see. So I should, this is address bus. I'm just changing the position. Okay. So this is a read signal. And also it goes write signal. Okay. Let's call it a shortened term R and W. And see, there is no bus notation, right? There is no slash and a number there. So by default in this diagram, we'll assume this is a single bit value, means one single line, electrical line connected from processor to the memory. Okay, so we do that. So what it is mean? So it means to the memory if write equals, so read equals 1 and write equals 0, then read operation, else if read equals 0 and write equals 1, then it's a write operation. Else, let's say we are modeling it as a do nothing. So that means when processor is when the processor is trying to read from the memory, it has to make the read signal as 1 and write signal as 0, send some address, let's say 1001, and get the value back from the memory. Get the value back from the memory. Now, when it tries to write something back to the memory, so what it need to do is need to set the write signal to 1 and read signal to 0, and then sets the address to, let's say, like 10 in our previous example, and send some data onto this data line. So let's say it sends 5. Okay. So in this process, electronically, processor is commanding memory that, hey, write the value 5 at the address 10. Question? Okay. Okay, maybe we can take like a 5-minute break at this point, but let me, before you go to the break, let me actually give you a problem to think. Just hold on. Maybe, oh no, okay, that's fine. But maybe we should skip the problem today, and then maybe next day we'll do the problem. Okay, let's yeah, let's come back. Let's wait for 5 minutes. Okay, break session, and then in the 5 minutes, like maybe at 7, we'll come back and discuss some more. Okay, let's get back to our discussion, that interesting one we were doing about the memories and processor relationship between them. And we hope, I hope that you have now some ideas on a different perspective. What is address bus, data bus, and what are the control signals, mainly read, write, etc. Now let's look at little more detail. Okay, let me see if we can cover it within our, we have 15 minutes more. So now we know that we have one actor called memory, which takes on control signal like read, write, takes a bus value, multi-bit value, that's a 32-bit, as address, and let's short form ADDR, and it takes 32-bit of data. And this is bidirectional. This is bidirectional. Now, we have another actor. Now let's call this actor as a controller. What we are trying to do is dive down into this processor. What is there in the processor? Processor is not a single actor itself. There are components within processor. So you can just think this way, right? This is a student community, and this is the rest of the student community, right? Your teachers, your university personnel, there are HR department and all this stuff, right? They have their functional role, and then as a whole, that's one acting body, but it has several smaller roles inside them itself as an organization, as a complex organization. So we are talking about that one. So one of the actor is a controller who is directly interfaced with the memory, read, write, address, and data from the memory comes up to the controller. And there is one actor we call a register file. So what is this registered file? This is registered file is nothing but a memory, but it is really fast memory, and only limited number of limited indices are present. Let's say in our processor, this is a memory which has index limited from 0 to 31. Let's say 32 storage space are only available, but they're blazing fast compared to the memory, and that is internal to the CPU, central processing unit. But as a model, this is still a kind of a memory with some difference. Okay, so common is read. So read is one common thing. Write is another common thing, like a memory. Address, ADDR. In this case, it would be 5-bit. Why it is 5-bit? Since there are 32 registers in this model, let's say we're defining, we need log base 2 of 32, take a ceiling value of that, which is 5 bits needed to encode address for RF as in register file. So address is this, and there is Okay, let me just put a gap. There is 32-bit for data in one direction, and also, okay, let me extend it there. Also for the reading, there is a separate 32-bit. Now, why we are maintaining separate read data and write data? So this is for the read, this is for the write. Because one thing is that this is within the CPU, it is within the hardware chip itself. So we don't need to worry about the space on the motherboard, which is maybe limited and crunching in space and stuff like that. Inside the processor, there is abundance of space. Let's just take it, okay? So that means without adding a complexity of maintaining a bidirectional electronic circuitry, we just make it simplified and made a separate data line for read and write. Okay, so we maintain that. So, okay, and there are some more happens since it is within the silicon, within the processor itself, and we have abundance of space there inside a processor. We actually go further beyond these. Like we actually have a separate address line for write, separate address line for DR for read. That's 5-bit. And in fact, we have two separate lines for the data, 32-bit to the controller. This is our read 2 and read 1. Okay. So there are separate address for read 1 and there is separate address for read 2. Now, why this? Because we want to retrieve two values. We want to retrieve two values at a time. And why so? Because usually the arithmetic operations we do, it is some kind of S equals A plus B, right? We have two operands simultaneously and some function to operator, right? So at this level, at this basic operation level, we always need to access two operands at a time. And these operands are temporarily stored in the register file. That means to make our process efficient, if we can parallelly read both operands together from the register file, then it will actually increase our efficiency. And that's why we want to maintain two different data output line from the register file for read 1 and read 2. And not only that, we also can do in parallel, we can do a write operation on this register file in parallel. Unlike the memory, read and write are sequential, we cannot do it in parallel. In the register file, we can do read and write in parallel. And that's why we have address line for write, address line for read 1, and address line for read 2. So that all these three operations, two read operation and one write operation, can go in parallel. Okay, so we started the register file as a very fast memory model. Then we expand that, deviate from our original memory model so far we have discussed, to make our life more efficient in terms of operation and relation between the controller and the register file. Okay, so far this is our understanding. Any question?
Yes, so which lines can run in parallel?
Controller can issue read and write in parallel for the register file. And for that, it can send 3 addresses, 1 for write, 2 for read in parallel. And after that instruction is given, let's say controller give both read and write. So what will register file do? It will take the incoming data and write it back in the some storage, wherever this write address is specified. And at the same time, it will return back 2 of this read data, which is from address R1 and address R2. Okay. I have one from the chat. I see. I just happened to. Okay. Is register file also called cache memory? Actually, no. Register file is not a cache memory. Cache memory will be discussing more towards the end of this. Oh, you are CS47. Okay. Wait for CS147. Cache memory goes there. Okay. But for you, it is not a cache memory. Okay. It's something else. Cache memory actually resides between controller and memory somewhere here. So it's controller interface with the cache memory, which is little bit faster than the main memory, and cache memory interface with the main memory. But let's not go into that complexity right now. Wait for 147 where we discuss it, and that too towards the end of the 147. Okay. Other question?
Professor, actually, I have a question. Can you tell me about the which chapter you are talking about the cache memory, and then which chapter can we read it on a book in a book?
Cache memory you don't need to read. This one is you just go through my note, like not specific in the chapter. These are first few lecture notes are from my experience.
Okay, thank you.
Okay, I have like 3 minutes. Let me just put some attention onto another component, and then we can adjourn from today, and we'll start from this point on the next class. So there is another important component called ALU. Okay, arithmetic logic unit. That's what the ALU stands for. What it does, it basically takes 2 values, operand 1, let's say 32-bit, operand 2, 32-bit, and some operation code. Let's say it is 5-bit operation code. Okay. And upon receiving this operation 1, operation 2, and operand 1, operand 2, and operation code, it gives out a value or result. Okay, so means what examples? For example, we send in, let's say a value of 5, and let's say controller sends a value of 10. And sends the operation codes that belongs to, let's say, plus. So result, so this ALU will send back to the controller result of 15. Now let's say the controller sends and let's say an operation of multiplication, operation code. Let's say 1 is add, 2 is multiplication, so on and so forth. Then this guy, ALU, will return a 32-bit result of 50. Okay, so that's the part of the ALU. So let me stop at this point tonight, and then we'll start from this point next day to understand the overall picture, the big picture. But you have these main component laid down for you. Okay, one is your register file, another is the memory, another main component controller, and the ALU, and together, these three together, your register file, controller, ALU, these together we called a processor. So processor mainly comprised of three components, main components, your controller, register file, ALU. These three together makes a processor, and memory is another entity. Processor memory goes directly onto the motherboard, and you can open up your computer and see them actually. But inside the processor, you cannot see. This goes directly into the chip hardware or the silicon. Okay, so if you have any question, just put it on module 1 QA, and we'll discuss from that point. Good night then.
Thank you.
Thank you, Professor.
Okay,
Appreciate
bye.
it.
Good night.
Good night.
Good
Thank
night.
you.
Good night.
Have a good
Thank
evening.
you.